Okay, now let's continue. Yeah, we understand the features. So, what are the things?
Give it a second.
Some technical difficulties. Okay. Yeah.
Oh, very impressive, guys. Very impressive. Thank you, thank you. I'm gonna paparazzi you. Looking into my son. Actually, that's a good thing.
So here are the flaws of the prototype. So first thing first, we have no power button. So the very so we need a remote. So it sometimes could be inconvenient when you forget your remote. Second thing, we have messy cables. So sometimes you don't know which connected to which. And we have the low voltage, which causes the buzzer to make a low frequency sound, and the cables can be easily unplugged because it's cheap as ultrasonic sensor has limitation because I broke the motion sensor.
The materials we need for this prototype is, well, it's quite simple. We need an ESP32 board, an ESP32, because that's the brain of the operation. That's where we put all the code and how it connects to Wi-Fi. Without that, the whole thing would probably could never exist. We also need a buzzer, because it's a buzzer, and a breadboard to put all the wirings in, so we don't have to create a more complicated mess than this thing already is. We also need all of the sensors that you probably just read out from the text. That's what it does. The vibrate sensor senses vibrate. Ultrasonic sensors uses sound to measure the distance between you to the device, and the IR receiver and remote will be able to receive IR sensors, so we can deactivate, or I can activate it or deactivate it whenever I can.
Okay, so the problems we faced during our very well-built IoT was what he said. He broke the motion sensor, which caused us to have setbacks, and the ESP32 as well. Another problems we faced is that the cables made us struggle so much due to the fact that at the first building process of our first model, the cables were all wrong. We failed to fix it multiple times, but now we got the hang of it, and now it's working. This is the main problem of the project as well. Would you like to explain?
Because due to the messy cables,
Iya bang, tokonya lagi
thought
tutup.
that this was positive, and I plugged it to the wrong port, which caused my hand to get electrocuted somehow. I don't know. And I broke 50K ESP32, and I don't know how to use motion sensor. Sorry, apa dulu ini?
Okay, our purpose, of course, is to reduce crime rates. As you can see, crime rate has been increasing. It had a decrease, but it's still increasing. It's still relevant right now, which is why we want to make this IoT to prevent it. Specifically, like car thefts and home invasions that are happening, and not people like mothers trying to catch their kids playing games. No, we're more into the thefts, which is why we're inspired to do this, so that people can also save more money, because I'm pretty sure our IoT is not that expensive. It's more cost efficient than what people have nowadays. And we're saving them emotionally. For example, if someone loses their stuff, it might cause emotional stress, where our IoT solves that problem.
So the future development of our of our IoT is probably to improve the design better. As you can see before, all of the messy wiring create like many setbacks. We couldn't receive sensors for it and everything. We also wanted to change the ultrasonic sensor into a motion sensor, as it is much better for this kind of implementation. And we also have to network it to Telegram. I haven't done that yet, that is my bad, but it's also the person who makes the thingy majiki board thing. It's well, not really mine. It should be. It's not like it.
Someone forget his email, how to spell it.
It's cat. So I think this is the most important part of our presentation. It's our learn journey. And while this is not all of the things, I'll explain what these things are. So first, of course, I already said there are the rules that we create to create rules for our AI to make the best of the AI. We also had to use a token and a Telegram bot. This is for networking. As we want to network this, it's actually very complicated because we have to network our computer to the Telegram, our computer to the thingy board, to the Telegram, and then to the device, which has a lot of complicated kind of reasoning that I cannot solve for now. So,
Iya bang, service TV nih, tapi bahasa Inggris.
So the problem we face in these days in the league is that, if I were to be honest, there was a lack of stats. Some people were really behind in the first 2 days, and they weren't able to catch up on the class. And then there's also the coding error that we'll have on the page, and also our AI not responding properly. For information, it just proves the level of time we have to do. And this is our documentation over these couple of days. And thank you guys.
Thank you.
Okay, let's move on.
Better plan. We set the center solo so you guys can succeed.
No, that's unfair. Okay, let's delete your team first already. Okay, someone want to press it. Let's see who is the next. Let's see who is the next. Okay, welcome Tommy.
Can you listen for a while before you present? Again, you will be presenting this in your respective campuses, right? So you can demo. I don't know how you can demo the prototype itself. So what I suggest is you take a recording of how it works. You record it, right? And then during the assembly, you just show how your system works. So in that way, the students in your campuses will have an idea of how your system works or your prototype works. Okay, is that clear? Okay. Okay, now may I return?
Okay, you guys may have some time after the presentation to record. So, come on. Come on.
Enggak sedikit, 21 doang. Ada orang nggak? Enggak, 21 doang. What?
Kayaknya ini anak-anak polos semua ya.
Hah?
Kayaknya lebih anak-anak polos semua.
Masih buram bang. Cianjur, wah saya lagi di Jawa Barat juga nih, Sekarang.
Okay, let's welcome Tambay.
Good morning, amazing people. So, my name is Jade. I technically helps coordinate this entire thing. So, meet my team, Dumb AI, and as the name implies, we are clearly unqualified to do this. So, my name is Chloe, and I did the documentation and the presentation.
Hello everyone, my name is Cam. I'm the one who built this IoT system for the group.
Hello, my name is Mason. I help with the code boost.
My name is Richard and I help with the windsurf.
Okay, so we don't have an epic story to tell. We only have a learning journey. And honestly, at the beginning already, it was quite rough because like we didn't know what to do. We did think of making the automatic water plant water first. Automatic plant water first. We did think of that. But then we got a class with another group, as you probably all know. Yes. And so we thought of different things. We thought of making a translator and then a door alarm bell and then so many other things. And then we came back to here because at the end of the day, we thought like, oh, okay, we're not gonna make this within 2 days. We only have 2 days. We can't do that. And so eventually we came back to here. I got the idea from a STEAM project we did back like a year ago. And we implemented and we just like fixed it from there. So a difficult beginning. So then what do you think this project could do? Okay, so let's make sure our audience is listening. Who's lazy? Raise your hand. Okay, that's not it. So I see no hands up, so that means we're all lazy. Okay, yes I know, you were screwed either way. So, alright, so back to our slides. Our project is amazing for lazy people. Okay, so remember this took like 2 days to do. So yes, we could add a sprinkler, we could have added a lot more things if we had more time, if we had more resources. But with the limited things we had,
BBS bang, Bina Bangsa School.
Some things that we could have solved. So the first one, of course, we're busy. So tell me right now. Should I ask? No, I don't want to. I'm gonna ask that. So okay, tell me right now. What's the first thing on your mind when you get on the bus today?
Tayo.
I don't know how to speak English. Ikaw 몰라요.
What are you going to think once you get into the bus? The first thing that you will think about.
Anyone want to volunteer? Any volunteer?
When you ride the bus.
Yay, we're done. Exactly.
Shame on you.
Exactly. We're not thinking about that plant we have back at home, okay, in our backyard, probably somewhere far. We're thinking about like, yay, we're back home. I want to sleep. And I also want to sleep right now. I'm not in my right mind. The second one, okay. Okay. The first one, so that's what it means, okay. It's difficult to ensure your plant is healthy. Because we're busy, we have a test. I have a quiz on Monday, and I clearly am not thinking this through. So the second one is self-explanatory. If you see there, I don't want to go up. If you see there, the leaf is yellow, and that's a snake plant, okay? That means we overwatered it. And so when we overwater it, what does it mean? It's dying. We clearly failed. And so when we fail that, there's no turning back, because a plant is life. Right? And we can't turn it back. And so we want to prevent that from happening. And so our system helps with that. To check if the plant is growing is quite difficult by only eyesight. You have to explain, I'm wearing glasses. I can't even see if it's 1 centimeter or 2 centimeters off. It'll be 5 centimeters off. So, and then the final one, it's difficult to make sure if the plant is correct, humidity and temperature. Self-explanatory too. If you look at like just this room right now,
Di
I bet
di Pik
anyone can guess
ada,
it's
di
like
Kebun
25
Jeruk
degrees,
ada,
but can anyone go to the exact
di Bandung ada,
decimal
Bang.
units? You make it. What? I'm guessing zero. What? The temperature of the room. Sure, it's really cold. It's shivering. Okay, whatever. Maybe 21 degrees. Okay, next slide. Alright, so I'm giving it to Mason. It's how it goes.
So this is our three goals. It send the data to inboard for the solution while also processing report to Telegram board. Second, ensure that you plan how enough water to getting the water pump to work. So this is our automatic plan system. It is affordable and convenient to build. It built in cheap price, so everyone can use it. When it's set up, it automatically plans the plans for us. It's saving time and effort. It also provides remotes to monitor your plans remotely. This is our three material is used. DH22 temperature humidity sensor. This is for humidity and the temperature. The second one is the jumper wire. Connect parts and carry Wi-Fi and Bluetooth. This is ESP32. Collects this 22 data, sends to cloud Wi-Fi Bluetooth, giga attention to limit.
There's four more materials used. First one is the breadboard. It diverts power so more sensors can work at once. And the soil moisture sensor, as you can see with the name, it detects the moisture in the soil. And the LED lights, we use the green, yellow, and red. Ken will explain later how it works in our system. An ultrasonic sensor will measure the ultrasonic waves. It will measure the height of the plant in our website.
Okay, so this is how we arrange our parts. Here we have okay, so here we have the ESP32, which is the brain of the system. And then here we have the breadboard to give powers for the sensors. This is the temperature sensor.
Guys, can you guys be quiet?
This is the temperature and humidity sensor. This is the ultrasonic sensor, and this is the soil moisture sensor. And the data from those sensors are transmitted directly to the ESP32 so that it can be processed and displayed in the Trik board like that. And we also have this LED which represent the conditions of the plant. It will be explained in next slide. Okay, we will demonstrate it here. You guys will see. Okay, so here when we change the, so this is dry, right? This is the soil moisture sensor. When it's dry, it shows 0%. And the light also shows red, which means that the soil is dry and it needs watering. We use this blue light to represent the water pump because we cannot connect to real world. So we use this to simulate it. Let's try putting it inside the wet tissue to simulate the soil. Okay, so when we put the soil moisture sensor in the wet tissue, the moisture went up and the pump also went off because the plants already have sufficient water and it doesn't need more watering. The light also changed. Here, it should show green, but I think it's frozen. Yeah, it's frozen. You can also monitor the temperature and humidity from it should show green, but I think it's really low. Back to the presentation. So this slide shows what. Okay, so this slide shows what the LED light represents. And the red light shows that the soil is not hydrated. The yellow light shows that it is moderately hydrated, and the green light shows that the condition is perfect.
So we face a lot of difficulties in this project. Firstly, there's a lot of errors during the comment pushes due to maybe clashes because me and a lot of other people were pushing at the same time. Then we also have a water pump malfunction. We do not have the correct wires to connect the water pump to the ESP32. And also there's the ultrasonic malfunction. As you can see before, when we were testing the prototype, the ultrasonic sensor was sensing -1 centimeter, which is very wrong. And then
Hello,
we also
hello.
have another soil moisture sensor bug. It was always showing 100% before, but camera fixed it. The telegram bot also takes a bit too long to respond to messages. The people management, as you can see, is very messy. And the download times of certain sensors are exceedingly long.
So moving on to the security. In order to ensure security, we use a token for the things board to limit the access only for the authorized user. And then we also use the same concept for API in order to link our project to Google services such as Google Calendar, for example.
So, as you can see, we learned how to integrate things board to PKC from what Ken showed. We also how to create different traffic lights. So this is really cool. It's the only thing that I'm proud of. Oh. Yeah, but at least the lights are working, like the red lights are working. If the one, okay. Oh, connecting Telegram to PKC. I made this one. Yeah, see? Now we can't show screen from. Wait, let's see. So you can just write report and you can get the daily report of the current readings. I'm gonna skip that one. How to make GitHub repository. I think you can already see from the screen as well. We were able to make a group folder in this case. And that is what we learned. We did learn a bunch more things, but to add it all to a slide will be extremely boring, so let's continue.
Okay, so this is what we want to learn next. First, we have how to use features in things more. Because since we just learned the basics now, right? I think it would be better if we could learn how to use more advanced features for our project to enhance it. And we can also know how to add the light sensor because everyone knows plants need basic stuff, right? Water and light, isn't it? And perhaps the light can measure how much light there is for the plant, so we can measure how much water we can give the plant. We can also data faster, so that's more efficient.
Duwi Arsana.
And we can learn how to integrate seawater to different species of genus of plants. This is our gallery over here.
Duwi.
This is Kent. He's working on the big
Duwi Arsana.
This is
PU.
also
WI.
I think she's working on the big and
II.
this is also us.
DUWI.
Next slide, please. And here we have Mason.
Maybe you can
Originally, we
search
were actually
Arsana.
gonna use the Mbot, but it was too difficult
Yeah.
for us, so we skipped that.
Yeah, that's
one.
one.
Our prototype before. And
Yeah.
here we're
Yes.
also testing our new prototype right now over there on the table. And this is here we're testing it again, untangling the wires too because it's really messy. And yeah, next slide please. Okay, so now we have a game, 2 lies and 1 truth. You guys have to identify which one is the truth and put on the 2 lies.
You guys want me to give microphone to someone?
Yes.
Okay, so go.
If you want to answer, just raise your hand, okay? We'll choose the one who raised their hand the fastest. The prize? Candy. You guys get candy. Okay, so the first one. When the yellow LED light lights up, it means that the plant is moderately hydrated. And the second one of the benefits of our project is that it is expensive. Number 3, our project is not multitasking friendly. Which one do you think? I'll give you guys 5 seconds to process everything.
Okay, who wants to volunteer?
Okay, raise your hand.
Okay.
First one's true.
Correct. Okay, I'll give you your candy.
Isn't it supposed to spot the lie?
Next one. Number 1, our project does not consist of an ultrasonic sensor. Number 2, our project monitors the plant humidity and temperature. And lastly, number 3, we have the proper wiring. Our water pump.
Jam
Again,
kerja,
I'll give
jam
you guys
kerja
5
sob.
seconds to process and you find out which one is the truth. Yeah, we cannot speak the same person twice, by the way.
Volunteer.
Okay, hands up. You, Sean.
Is it? Where is he? It's 2 or 3. It's not. Okay, I would think it's 2.
Correct. Here's your candy. And that's all for our presentation. Thank you so much.
Okay, what a good presentation. Good. Yeah. Okay. Now, I really need the IoT device for minimum effort to take care of my plants at my house. But anyway. Now, do you guys want to click the button for? Okay. Yes.
Jade, if you roll our group, I will personally blame you.
Okay. Let's see. Is it group 4?
Group 6, group 6.
Oh, I jinxed it! I jinxed it! No! I jinxed it! James! How dare you!
Okay, come here. Welcome, team! Clear team! I love the drama.
Up.
Oh, no. Lupa dibuka itu. James, where are you?
Ada berapa orang lagi ya? Dikit 30. Oh iya, maju aja ya.
They're live streaming. Yeah, exactly. They're live streaming it. Well, like.
How many viewers is there right now?
Currently we are at how many viewers? How many viewers?
30, just only 30.
Okay, 30 people is watching.
Wait, okay.
Let me send it to the Discord.
No.
Oh, read it. I'm gonna send it to the IGCC Discord and say this is CS practice.
What?
Iya.
What's for CS practice?
I need to do some setting up first, guys. Give me a bit. Okay, bro. Oh, shoot. You know what? Let me. No, wait.
So,
Okay, wait. This
focus
is actually so confusing. What is going on?
Sorry.
Okay. Please work. Oh my gosh, where is it? No, this is not our PowerPoint, guys. Don't worry about it.
We have some technical difficulties.
This is what happens like every single time.
Okay, finally, we got it to work.
Give a sec. Who is playing the looking at the live? Can we turn off the voice or something? Turn off the. Is it because the computer is playing the live?
Oh no, I think it's not because of my laptop's muted. Oh wait, yeah, it actually might have been my laptop.
Good.
Okay.
Okay, let's start.
Yeah. So, once again, good morning everybody in this room. We are team number 4, Team Clarity. And without further ado, let's move on to why is it not? Okay, let's move on to our introductions. Let's meet our team. First of all, hello, good morning. I am Owen, and okay, not again. Sorry guys, this is gonna be one of our difficulties today. Okay, once again, hi. My name is Owen, and in our team, I focus on tech support for my team, the merging of the different modules that my teammates made, and the integration of our project with ThinkSport. In terms of leadership, I led the team in project coordination, sprint management, and technical direction. And my main breakthrough this project was the moment when I compiled all of my teammates' modules into one finished Arduino program for our finished prototype.
Okay, hello guys, I'm Gwen. As you can see here, I went from a learner to a peer teacher in one day, and I'm a hands-on learner who likes experimenting and solve problems by actually trying things out. I've been learning how to use PPC and Docker for legit 12 hours every single day, working day and night on a computer. But I have made a lot of achievements, including my installation of BMAD, and all the applications I need to make my life management system. I also enjoy working with teams and hate how this PPT has 400 slides. A wise one once said, clarity equals to growing comfort and sensing every change. Next.
Hi, my name is Federico, and I used PMAP to climate control, and my breakthrough was the climate control one.
I'm Anson, and throughout my learning experience, I've been confused so I get help, and now I get a little bit more. And the philosophy, this is what AI said. And my contribution is I helped in the soil monitoring module and Telegram bot integration.
Hello, I'm Jason. I did this Telegram bot for more than 6 hours. And I helped with everyone else just get up and stuff.
So the materials are the ESP32, which is like the brain. It's the place where it gets the information and makes decisions out of it. And then there's the sensors, which senses, it just senses. And then the software is the Arduino, which is where you can code the ESP32 from. And also the base board, which gives a visualization of the data. And then also the AI, which the AI can make a full report of the data given by the sensors.
So if we can look at the collection of our very wonderful sensors, we have the ESP32 as our main board. We have a light sensor, 3 LEDs, 4 actually, including the one stuck on the main board, the DHT22 humidity sensor, the flame sensor, which unfortunately we ended up not using, and finally the soil moisture sensor. So, what have we done? Not in terms of something bad, but what have we done? Any guesses? Come on, guys. Not even one person wants to raise their hand.
One person if no one says anything.
Okay, who do you want to choose?
I'm gonna give you candy, guys. Just like the last group. No, you rolled us. I'm gonna copy your strategy now. Okay. That guy over there. Hello.
Yellow jacket.
Yellow jacket.
I just answered.
What did you just answer?
No.
The.
No, this group.
I don't want to do it for you. Oh, you will do it? Okay.
Oh man, how about you? Ah, yes.
The light sensor.
Wrong. We used the ESP32.
Yes. We basically use the ESP32 to read data from the sensors, like for the light, temperature, soil humidity, and the flame, in case someone drops a match and sets the place on fire. We also use the simulation and in real life to connect it to the Arduino and basically make our whole code. And we used it to connect to the Telegram bot, to the Arduino stuff, and it connects all the things that we learned over the past few days together, and it is also the start of our term. Okay, sorry.
And so, after all of this has been explained, the materials, let's move on to our epic story. Epic story with many ups and even more downs. Trust me, I think all of our brains have exploded in this project. So let's get straight into it.
Okay, why our product? As you can see on the screen, I've wrote down some parts of why you should pick our product. Since we don't need to waste time going back and forth to our greenhouse to see how we're doing, we have a perfect light control, and you can automatically just adjust all your shades at once, so you don't have to go back and forth to see if your plant is dying. So it also prevents the plant stress, which can weaken the plant. And as one of the last groups said, if the leaves don't get enough of their nutrients, they can turn yellow and ultimately they can die. Other than that, It saves energy, it ensures that the fire safety is on and instant fire detection, and it also sends an immediate alert to monitor soil moisture. Okay. And healthier plants produces a bigger harvest, which means bigger profit.
Our vision is to sustain a sustainable tech and science that can enhance agriculture, a scalable solution for farmers, share our knowledge with the world.
Okay. So roll the vision. First, let's answer.
So what I did was I integrate the soil moisture sensor and the water pump to the ESP32. And then the soil moisture sensor will send data to the ESP32. And then from there, ESP32 will decide whether it's wet or not. And if it's wet, it'll like off the water pump, not the we don't have the water pump, but we simulate.
I installed the DHT22 sensors in 3 phones to actively monitor temperature and humidity. Second, I implemented fan control logic using LED as a replacement for the actual fan system during testing to simulate the fan's operation. Next, I developed servo automation that allowed the windows to open and close automatically. Finally, I created threshold-based environmental rules so the system could respond to changing conditions based on predefined parameters.
Okay, so these are some of the things that we did. I documented everything. So I basically took all the videos, took all the pictures. As you can see right here, these are my codes. I also made the light control module, which connects to 2 items over here: threshold, configuration guide, and the IoT smart shade system. So, first, what is a threshold configuration guide? Well, it's basically using the BA1750 sensor to measure the brightness. So if it's too high, the shade closes, but if it's too low, the shade opens. And the user can still manually move this by moving it up and down, side to side, anytime. So it's like you can have any manual changes. So what does the light control module do? So you know when it's too bright, it's basically the same thing, it just closes, and if it's too low, it opens. Okay, so I'll skip to why it's helpful. So it makes our system easy to adjust for different environments and helps our team test and improve lighting logic and saves time when you make changes later.
Langsung ya Pak? Direct dari
Let's motivate Jason, guys!
First of all, I focus on Telegram bot integration with Kingsport. It is a critical part of our system that enables real-time communication and automated control. I also received support from GitHub, which is a valuable source for our development. This support helps ensure that all team contributions can easily be accessed and collaborated on. We are all very grateful for
And finally, I did the GitHub support. I was basically the tech support of the team. I still remember when Anson and Federico could not commit anything to the JIT for the love of them because they forgot to configure their GitHub with their username and email. And second, I also merged my teammates' Arduino contributions. Federico worked on the soil moisture. Anson worked on the soil moisture. Federico worked on the climate control, and Gwyneth worked on the light sensing system. So I took those three modules, combined them together, added a little bit of my own code, and boom, we have the full working code for the IoT now. And I also integrated IoT into PKC, and I integrated the ESP32 into the Things board. So, we would like to give a special thanks to our extra team member, Ms. Happy, for providing us emotional support throughout the entire thing. Thank you so much, Miss. Now, next up, we have a lot of difficulties in our team. Just like I said earlier in the beginning of the presentation, our team has gone through a lot of difficulties. Especially yesterday night, ya tete ayam tahu-tahu aja. If you know what happened last night.
First, we had multiple problems in pushing and pulling the data and connecting the things port to the Telegram. Third, our LED got hurt.
I burnt our LED, which is because it was connected the wrong way. This was basically if you connect a conveyor belt the other way around, this
Halo,
doesn't work.
siang.
You don't connect the female and the male or like.
He put the positive to the negative to the positive, and boom, explosion. We actually smelled smoke.
I was the one who broke it. There's several problems with us using GitHub. Our commits keep clashing and it won't merge unless we ask the AI to merge it for us. Why? It's because we're new to GitHub, some of us. And our lesson is we learn how to use GitHub to avoid this issue.
Has anybody else in your group had your GitHub commits turned into this colorful spaghetti right here?
Mac does this 1,000 times.
We did this too much, and oh my gosh, it's
For those who says no, it's because you didn't use it at all. Not enough.
Oh, no wonder.
Okay?
These are snitch. Okay.
This is what a product should look like.
We have a lot. We have a lot of terminal errors. Everything from Git, it's not configured to npm none. We were new to this terminal errors thing. We had to ask the AI to fix it for us again. And our lesson is you can navigate this issue now.
Next is the full PKC integration. Oh my days, I spent nearly a day with this. I finished the full Arduino code by the morning or the afternoon of yesterday, and I spent the rest of the day trying to integrate that thing into PKC. Connecting it from ThingsBoard to PKC, the time when I was trying to sign it to ThingsBoard and suddenly the server just exploded. You remember that, Alessandro? And I still remember chasing around Alessandro, Padri, Mr. Henry, chasing him around all day long trying to ask, how do you integrate this thing into PKC? Well, I finally did it, sorta, in a halfway state. It shows up in the PKC terminal, but it doesn't really link to the RAG chat. We haven't imported the data to the M card, and we also haven't figured out that daily report thing that we included in our proposal. So why? Well, because we were simply clueless about sending ThingsBoard data to M card and RAG, because of course we're new to this. And because of that, we learned more about these two systems along the way.
Okay, this is your part, Jason.
I took his part.
Go ahead, Jason.
Telegram integration is really difficult because it doesn't work most of the time, and it's our first time using Telegram.
We will let all the burden go to him.
Sorry, Jason.
Nobody else worked on this.
Go ahead. Carry on.
But did it work in the end? It did.
No,
Yeah, it's
Oh,
worked.
man.
Okay. Continue, continue.
some of us worked. My lesson from this is to learn from that failure and just fix it every time, and it still won't probably work.
So let's talk about the future of our project. What do we aim to change about it if we're given more time to reflect on it and improve on it after this?
And do a practice round.
Practice round.
So, what are we aiming to fix in the future? So, as you can see here, we already had a lot of issues in the PKC, as what Federico or Anson, I forgot, mentioned before. So, we aim to fix that by still consulting to our mentors and using the real parts instead of the simulation, because I think the simulation had a lot of problems too. So we plan to use the real parts to test and trial our project. And this fixes all our basic troubleshooting needs, like the terminal errors.
So our first aim in the future is to get these daily reports working. I think the daily report system was one of the most major parts of our original proposal when we presented about our project plan at the night of day 2. We originally envisioned a system where the Things board can send data to PKC, PKC can digest that data and send the data to the user as an easily digestible daily report of how much water the greenhouse used, what was the average temperature and the average humidity, and hopefully send emergency alerts to the user as well if there were any problems happening with the system. Sadly, we never got that to work throughout these 3 days, and if we were given more time, we hopefully want to get this working. Why? Because our original vision for this project is to have this daily report system, and sadly, we didn't deliver. So if we could improve it, we would add this feature.
Sole purpose.
So we don't have a water pump, so use LED instead. So so hopefully in the future we can integrate that in like our project.
Now let's move on to our project demonstration. I'm sorry if you can't see this, guys. Our IoT thing is really small. I'll just open my PKC real quick. Okay, here is our, can someone grab the glass of water from our table with a piece of paper inside of it? So, this is our Things board dashboard for our IoT project. As you can see, it sort of shows a visualization of the temperature. You can see that the temperature is 20. We're like freezing up here.
It's so cold in here, guys.
Oh, definitely. And the one that's easier to show you in the interest of time is the soil moisture. So if you watch, the soil moisture percent is currently at 0, but if I put this inside the glass of water, 93%.
The third one, look at the third one.
Yeah.
Wow. Wow.
We wanted to show you the rest, but in the interest of time, we need to finish this presentation quickly. I'm sorry, guys. Let's go back to the presentation.
We have fire.
Yeah.
We have soil moisture, which is the one that we just did before.
Yeah, and if these parameters fall below a certain threshold, some of these LEDs will turn on or turn off to simulate the fan, the window, and the pump turning on and off, since we don't have actual fans, windows, and pumps.
In the
first project.
Yep. And so, to end off this presentation, we would like to give a very special thanks to our mentors, Alessandro, Padui, Tokoku, Pak Stefanus. Thank you, everybody. I'm sorry for bullying you guys throughout the days, asking you guys for help all day long. Especially you Alessandro, when I disturbed your Zoom meeting. I'm so sorry, sir.
Okay, thank you.
Thank you, everyone.
Okay, the first group that presented a working things PC and also work with GitHub. Okay, very good, very good. Now, we're gonna have 15 minutes for rest, right? Yeah.
Sorry for taking your time, guys.
15 minutes, 15 minutes, so it will be until 40, okay? Please come back at 10:40. Okay, there's no late. Okay, you have to come back at 10:40. That's something you have to do.
Trainers, we have a